Hello students, welcome to the Mechanics of Materials online lectures. Today we will continue our torsion study, and in these lectures I will discuss power transmission. So as you see in these pictures, there is a belt, this belt this is a belt drive system, and this belt drive system, the belt transmits the torque developed by an electric motor located at B to a shaft at A. So we will learn how to calculate the power, and then how to, based on these powers and the torques, how can we determine the diameter of the shaft to design such kind of system. Now, so the power transmission and the design of transmission shafts. As we know, power is defined as the work performed per unit of time. Now, the work transmitted by a rotating shaft equal to applied torque multiplied by angle of rotation. Now, if the work is defined by W, we denotes work by W, and torque is T, and angle of rotation is theta. So W is equal to T multiplied by theta, and the power P is equal to work done divided by time interval. So the power is the amount of work that is carried out during a certain time. So we can say W by T power, and if we plug W is equal to T theta, so P is equal to T theta divided by small caps T. Now, theta by t is angular velocity. So similarly, as we know, this distance by t is linear velocity. Similarly, the angle of rotation divided by t is the angular velocity, which can be denoted by omega. So P is T multiplied by omega. So P is the torque and omega is angular velocity. And we also know angular velocity omega equal to 2 pi f. Okay, omega is equal to 2 pi f. F is frequency of rotation. In other words, F is, we can say F also, we can say the number of revolution, the number of revolution per second. Okay, now if this is my equation number 1, if we replaced omega with the f, we can write 2 pi f multiplied by t. So this is another equation. These are the two equations for the power. P is equal to T omega, or P is equal to twice pi f t. Now let's solve a problem. This problem is available in the book, and this is the problem we are going to solve soon. And this is the problem number 5.4, example 5.4, in page number 193. This is in 193 page, example 5.4, page number 193. Okay, so in this problem, as you see, there is a motor, and this motor, which is located at M, this motor transmit 5 horsepower using a shaft AB, and the shaft rotates 175 rpm, and the shaft is made of steel, and the allowable shear stress of the steel is 14.5 ksi. Determine the required diameter of the shaft to the nearest 1/8 inch. So the P is given. P is 5 horsepower. Okay, and the angular velocity omega is 175 rpm, and allowable stress tau allowable is 14.5 ksi. Now we need to determine the diameter of the shaft. We need to determine the diameter of the shaft. So now this problem is given, and if the value here ksi is an FPS unit, so we need to convert the other parameter horsepowers and also the RPM to FPS units. Now 1 horsepower equal to 550 feet pound per second. Okay, so the P is 5 multiplied 550 feet pound per second equal to 2750 pound feet per second. Okay, and omega equal to 175 RPM. Okay, and 1 RPM equal to twice pi divided by 60 radian per second. So the omega we would like to convert it to radian per second. So 175 multiplied by 2 pi divided by 60 radian per second equal to 18.33 radian per second. Okay, now we know just a few minutes ago we learned P is equal to T multiplied by omega. So P is equal to T multiplied by omega. So if we rearrange this, P is equal to T by multiplied by omega. If we rearrange these, we can write T is equal to P by omega. So we know the P is 2750. P is 2750 feet pound per second, and omega is equal to 18.33 radian per second. Okay, Now if I calculate that, the final value is 150.1 feet pound. Now previously we learned the torsion formula, tau max, shear stress due to torsion, maximum shear stress due to torsion equal to torque multiplied by radius of the shaft divided by Z. Now here tau max equal to tau allowable stress. So we can rewrite that equation equal to TCJ, and we can rewrite these J by C equal to T by tau allow, and we know J is equal to pi by 2 C to the power 4 divided by C, and T is equal to T by tau allow. Okay, so C cube pi by 2 T tau allow. Okay, we can write C cube equal to 2 by pi T tau allow. C cube equal to 2 by pi. Now T is 150.1 feet pound, and tau allowable is 14.5 KSI. Okay, tau is 14.5 KSI. Now C cube, now I need to be consistent with the unit, so it's a kilo pounds per inch square, 14.5 kilo pounds per inch square, but my torque is it feet pound, so I have to convert the feet to pound, feet to inch. So 150.1 multiplied by 12 inch pound, we have actually here 2 by pi, so 14.5 multiplied by 10 to the 3 pound inch square. Now as you know, the one we multiplied 14.5 with 10 to the with 1000 because it is in kilo pounds inch square, make it pounds inch square. Now if I so this is 2 by pi 150.1 multiplied by 12, 14.5 into 10 to the power 3 pound inch square, okay. The C cube I changed to the 1/3 to the power 1/3 because I need the value of C. So the value of C is 0.429 inch. Now in the question, if you remember in the question, so it is asked to find the diameter of the shaft and C is the radius of the shaft. So the diameter is D equal to 2C. So 2 multiplied by 0.429 inch, which is, so D is 0.858 inch. Now the question says determine the required diameter of the shaft to the nearest 1/8 inch. Let me explain this one. So when you want to buy some rod with some specific dimension, in the market you will not get exactly the same dimension, 0.858. Usually the diameter start with, say for example, 1/8 inch, say 3/8 inch, 5/8, 7/8 inch. Okay, so you have to select a rod which diameter closely matches with this. Okay, and this one 7/8 is 0.875 and 5/8 is 0.625. Okay, and 1 inch, the next is 1 inch. So this 0.858 is pretty close to 0.875. So this 0.875. So the required diameter is 0.875 inch. So this is the answer, 0.875 inch. This is the answer of the problem. Now we will move on and we're gonna solve another problem. This is a problem. We're gonna solve two problems from the book. This is problem 5-35 and 5-36. These problem are from the book, and you will find this problem page number 202. Now just first let's read the description of the problem. The shaft, 25 millimeter diameter shaft on the motor is made of a material which has an allowable shear stress 75 megapascal. Sorry, here the T is actually should be tau. Let me bring this from here. to, it should be tau. Now if the so it is given that shaft diameter is 25 millimeter and the allowable stress is of the shaft is 75 megapascal. If the motor is operating at its maximum power of 5 kilowatt, determine the minimum allowable rotation of the shaft. So let's solve this problem. So given is a 535, given tau allowable is 75 megapascal and the C is D by 2. D is 25 so D is 25, so C is 12.5 millimeter and the power is 5 kilowatt. Now what is the minimum allowable rotation? So we have to find the omega. So we know P is equal to T omega, and we also know tau allowable equal to Tc divided by Z. Okay. Now here to find the torque, so T is equal to tau allow multiplied by J divided by C. Okay, so tau allow is equal to 75 megapascal. J is equal to pi by 2C4 divided by C. So 75, we need to convert it to the Pascal, multiplied by 10 to the power 6, then pi by 2 C cube. C4 divided by C is C cube. Okay. Now 75 10 to the power 6 Pascal pi by 2 C we know 12.5, so 12.5 is 0.0125 meter, 0.0125 meter cube. So if I take the T is going to be, if I calculate these values, this is 230.10 Newton meter. Okay, 230.10 Newton meter. Now here if I rearrange, now omega is equal to P by T. Omega is equal to P, we know the 5 kilowatt, and T is um, sorry, I think the T, yeah, T is 230.10 Newton meter, and this is 20. Now 5 into 10 to the 3, we need to convert the kilowatt to watt, and 230.10 Newton meter. So omega equal to 21.7 radian per second. So this is the answer of problem number 535. Okay, now let's move on to the second problem, which is 536. Now here it is saying that the allowable stress is also 75 megapascal, and it says if the outer diameter of the tubular shaft is 20 millimeter and the wall thickness is 2.5 millimeter, determine the maximum allowable power that can be supplied to the motor. And the angular velocity should be 1500 revolution, and let me correct this one, 1500 revolution should be per minute. Now to solve this problem, so this problem says 536 problem says your omega is 1500 rpm and tau allowable is 75 megapascal. Okay, now this problem, it says that the shaft is a tube. So if this is the cross section, outer diameter of the shaft is 20 millimeter, and wall thickness, that means this thickness of the shaft is 2.5 millimeter. That says the inside diameter of the shaft is CI is 20 by 2 minus 2.5 millimeter. That means 7.5 millimeter. So CI is 7.5 millimeter. CO is equal to 20 by 2, 10 millimeter is equal to, this is 0.0075 meter, and this is 0.01 meter. Okay, now It is given P equal to T omega and T equal to P by omega. So we don't know the P. Actually P we need to find out. Omega is equal to 1500. So omega equal to 1500 RPM. We need to convert it to radian per second. 1500 multiplied by 2 pi radian divided 60 second equal to 157.08 radian per second. So the T equal to P by, you're going to plug the value of omega, 157.08. P is in watt, so we don't need to write P, write anything P, then radian per second. And we also know tau allow equal to T C by J. Now here our J is, since this is a hollow cylinder, so the formula for the J is pi by 2 C outer radius to the power 4 minus C inner radius to the power 4. So we know pi by 2 CO is 10 millimeter, also 0.01 meter, and CI is 0.0075 to the power 4 meter. Let me write it here again. So J is equal to, this is 2 just as pi by 2.01 meter minus 0.0075 meter to the power 4. Okay. Now if I take these values, J is equal to 1.0738 10 to the power minus 8 meter 4. So this is the value of J. Now as we know that T tau allow is equal to TC by J, we can write T equal to tau allow multiplied by J over C. So here, from here we know T is equal to P by 157.08. So we plug this, we substitute T with this P by 157.08 radian per second. Tau allow is 75 megapascal multiplied by J, we just found 1.07 3 10 to the power minus 8 and C here is 0.01 meter, and this is actually also meter 4, sorry, meter 4. Now here I need to convert these to 75 into 10 to the power 6 Pascal multiplied by 1.073 10 to the power minus 8 m4.01, and this one, if we multiply 157.08 radian per second is equal to P. Sorry, it can't be 8. 157.08 multiplied 75 10 to the power 6 Pascal and multiplied 1.073 10 to the power minus 8 divided by 0.01. So if I calculate it correctly, the result is 12650.28 watt, which is 12.65 kilowatt. This is the answer. This is the power required to run this shaft at 1500 RPM. So to solve this kind of problem, it's few things you need to be careful. One is a consistency with the units. So convert your omega to, if it is RPM, convert it to radian per second. If your power is in horsepower, convert it to feet pound per second, or if it is in an SI unit, convert it to watt. Okay, so these two conversions, this type of conversions are very crucial to solve those problems. So that's why when you solve the problem, please check your unit very carefully. So that's all for today. I already uploaded the homework 5, and the homework 5 is due next Thursday. The coming Thursday. You can find it on the, I emailed yesterday night. Homework 4 is due tomorrow, so please solve those homeworks and watch these lectures. Stay healthy, be safe. See you in the next class. Thank you very much.